Dr. Bhomia, we're online now and we are ready to start. So welcome to the next lecture in the MS Swaminathan Centenary Lecture Series. So July happens to be the month in which the World Mangrove Day is declared, which is 26th of July, with mangrove ecosystems to give us a talk today and tell us about. So he will be Dr. Rupesh Bhomia, is formerly from C4 ISRAF. He's an accomplished environmental scientist with over 2 decades of transdisciplinary research and applied experience in resilience. He holds a PhD in soil and water sciences from the University of Florida and dual master's degrees from the University of Oxford and the Jawaharlal Nehru University in Delhi. His work integrates field-based research, teaching, science policy engagement, and capacity development across more than a dozen countries in Asia, Africa, and the Americas. Today, he will be talking to us about advancing mangrove science in India, monitoring strategies for climate resilience. And thank you.
Thank you so much. Hello, everyone. As it was introduced, this is the month when International Day for Conservation of Mangroves is celebrated. So it is my absolute honor and a privilege to be able to speak about mangrove science at this sanitary lecture series for MS Swaminathan, sir. So thank you. Talk for me is to celebrate pioneering spirit and living legacy of Dr. Swaminathan by recognizing scientific research as core pillar of sustainability. And with that, I'll start to basically have to cover a lot of ground. What I'll try to give you a little bit of context in which our today's talk and discussion will happen. Then some of the challenges followed by some of the solutions that we as a humanity, as a society face. And then, as I said, in terms of livelihoods, in terms of well-being, in terms of our future growth. And then how do we come about it? So I'll discuss a little bit about innovative partnerships and then share some of the big picture global sustainability, and then leave you all with some of my personal reflections. Before I go further, I just want to highlight and acknowledge the plethora of institutions, individuals, researchers, scientists, members, project members, field staff, boatmen, and people who have supported us during conducting this research. So really acknowledge support making this possible. So when we look around, we often see ourselves thinking about the changes that we are seeing and noting, and keeps on suggesting how this year has been the hottest on the planet, and the record has been broken. If we look at the last reports by World Meteorological Organizations of these changes, if you look at the temperature anomaly, the graph on the right top, what you see is that last several years have been, as shown in the red, has been very much higher temperature. If you look at the bottom two to paint the picture of what climate change and our changing world means. So what it tells us, due to the temperature anomalies and the precipitation anomalies, is that some of the areas are going to be really warmer, while some of the areas will be going to be much more colder. Some areas across the world are going to be much more wetter. Some areas will get much more drier. And then there is these extremes. So what we are seeing increasingly is the departure from normal, the average, what the world has seen fast. So we talk about a little bit of ecological baselines and how the ecological world is responding to that in the context of this climate change. And when we look what it means in the context of mean sea level, then this graph is also presented by this World Meteorological Organization. What we see in the last 30 years, heading up of this increasing global mean sea level. And this change is in the positive direction. What you see is in this graph, if you look at the last half, this incline has been much more steeper. Mean sea level has increased with time. So what it presents is a very large global challenge, because when we're talking about global mean sea level, it is affecting all places across the globe, but no country which has coastal boundary, which has coastal ecosystem, will be affected. And if a country is insular, which means it doesn't have a coastal boundary, it is still affected, because a lot of economic and trade does happen through our coastal settings or systems. So when we look in the context of sustainability, and specifically the lens of this rise in global mean sea level, then what it results is, it paints a picture of how things are really interconnected and going to be really impacting. So when we see the rise in sea level, that means there will be higher coastal erosion, and there will be more incidences of flooding on infrastructure. It will have an impact on soil and water salinization, and a direct impact on biodiversity changes and losses, for example, fisheries and so on and so forth. All of this boils down ultimately to reduce livelihoods, causing displacement, conflicts, food insecurity, where our sustainable development goals are impacted. If you see here, out of our 18 or 17 sustainable development goals, 12 of them are represented here, which are going to be impacted. Same is the case with the precipitation. When we look at the anomalies, look at them, sustainable development goals are becoming harder and harder for countries to achieve, for societies to adapt to. So this presents a picture of why this is important, why understanding, recognizing, realizing, and then doing efforts to address climate change is very much important. And it is considered to be one of the biggest contemporary challenges of our times. What can we do about it? Then how do we combat this climate change? So the two very often used terms that you may have already heard about is mitigation and adaptation. Mitigation in simple terms means how can you reduce so the greenhouse gas emissions which are going on, can we reduce them? Can we sequester some of the greenhouse gases which has already gone into the environment? Can we find a better secure place for them? So that is one aspect which is called mitigation. Second is adaptation. How can adapt to live in this changed environment, in changed climate? And those two actions, mitigation and adaptation, kind of go hand in hand if we are to survive in this changed global climate scenarios. What you see of the action strategies which combine both those aspects. So there are actions for water conservation, which not only reduce the emission of greenhouse gases, but also allow us to adapt to the situation where there are more droughts, where there are more shortages of water. So what we see here is in the center are the what we call win-win strategies, which will mitigate. When we look at these win-win strategies, what is very clear to us right from the beginning are any strategy which involve natural ecosystems, working with nature, fall in this win-win categories. In this case, carbon can be stored in Earth's ecosystem. And what you see here on the cartoon are different ecosystems, different biomes with their estimated capacity of tons of carbon storage per hectare, values of carbon storage in terms of tons. But if that ecosystem is protected, it does provide a lot of additional benefits in terms of ecosystem services, in terms of biodiversity protection, in terms of reduced vulnerabilities. Natural ecosystem or working with nature is provide us with win-win strategy. What is very important here is to draw your attention towards wetlands as an ecosystem. What they are very, very good at is storing a lot of carbon, much to underground, which is below ground. They can do that. Wetlands are able to do that because the carbon that is sequestered is hidden away from oxygen. So it doesn't get mineralized, it doesn't get decomposed, and it can be stored for longer duration. They can build up sheer ability or capacity for carbon storage. So that commonsensically will allow us to see why wetlands can be one of the best possible avenues or options when we think about addressing climate change. And when we look at wetlands, one specific kind of wetlands comes to mind, which are coast-specific categories have been identified as blue carbon ecosystems. These are salt marshes, seagrasses, and mangroves. Three of them combined are known as blue carbon ecosystem because of their high capacity as well as in the vegetation biomes. Also, as I mentioned, these ecosystems are very important for sustaining various services, which involves regulating services, provisioning services, supporting services, and cultural services, and are very, very important for maintaining seascape. So that's why these blue carbon ecosystems can be a very good candidate for preparing strategies for climate change adaptation and mitigation. When we look at these extent of these blue carbon ecosystem, they are present across the globe. Out of this contain at least one kind of blue carbon ecosystem in all. These are strategies that have global applicability. The countries can apply, so there is a potential for collaboration, cross-learning, replicating some of the successes and learning from challenges. So it is not just one particular country or few. Every countries can take some action and the impacts will be felt globally. So that gives us a lot of confidence in designing strategies that can be applied in these blue carbon ecosystems. When we look at mangroves, as I was mentioning, and I'm particularly fond, are one of the superheroes for carbon dioxide sequestration. Per unit area, mangroves are known to sequester 1 to 3 times more carbon than any other ecosystem on land. And as I was saying, most of this carbon, if you will. Other than that, storing carbon, mangroves are very important for providing safety net against any kind of extreme events such as tsunamis, storm surges, or any storm. If I recall the term, which was, I believe, coined by MSS bioshields. Mangroves are known as bioshields because of their ability to shield the communities and society system. They also provide very unique biodiversity habitat, and a lot of species survive in these areas. And due to their interconnectedness, due to their uniqueness, there is always a lot of services and products that are derived from mangroves. For example, many medicinal values, for example, food, for example, livelihood avenues. Very common in these days is mangrove tourism, which is coming up as a new arena for people who really want to spend some time under mangrove shade. So although I've painted a very, very interesting globally is that mangrove has been lost since last several decades. Globally, about more than 5,000 square kilometers of mangroves have been lost. And when you look at the hotspot of these change, what you see is from Africa and some from South America and Central America. But about 50% of this loss has come from Southeast Asia. So when you look at these changes, one needs to think why these losses are happening for such an important ecosystem. So when we drivers, because it is not just cutting off trees that can lead to loss of a mangrove, but there are drivers which are environmental drivers such as climate change or extreme event which can cause loss of mangroves. But there are anthropogenic drivers, for example, aquaculture, agriculture, settlement, industrialization, pollution. Drivers, when they combine together, they not only result in mangrove degradation and loss, but they also form this complex, interconnected challenge where they both work in tandem. So it is very difficult to just say will be restored back to its natural form. So to understand how the drivers come about or how they act and sort of strengthen each other or reinforce each other is very important. This is just some snapshot of showing a picture where huge swaths of mangroves are pretty much died after tsunami of 2004. This is an aerial shot of an area from Indonesia. What you see in this picture now used to be all mangroves. And then the other photo, which this one, is where they have done some effort in mangrove restoration. So some of the mangrove have started to come around in the villages. But this is the imagery to show anthropogenic drivers or causes of loss. Once you identify the drivers, you need to understand what are driving these drivers, what are the underlying causes. So it is a good typology to look at their drivers in terms of scale, spatial scale, as well as temporal scale. And there's an interesting paper which came out a few years ago where authors have tried to look at this particular situation, and they look at the scale aspect in context of climate, that even for the climate, there are things which are important in the context of very small spatial scale and very small temporal scale. So localized and in days, for example, storm freezes in areas which will result into mangrove drought. In the context of direct human effect, you can also look into this. For example, clearing could be at a very small temporal scale. It could be immediate and very localized, whereas in terms of its temporal scale, it could be few years. Then an invasive species may impact ecosystem. When these two combine, as I was showing earlier, that is reinforced by increased emission, enforced because the ecosystem's ability, resilience has reduced. And all of this ultimately result in loss of ecosystem benefits and processes, functions, goods and services that we as a society ultimately depend upon. So what do you do about what's the change, but how do you address it? That's where I think research comes into picture. That's where the generation of research action. And what I'm going to share in this presentation is to sort of emphasize that when you identify the problem, when you identify the risk, sit down and work towards a strategy, a history to generate credible and some information that will help you to inform policies and then provide some of the avenues for that. And in this context, I won't dwell on it, but this is what I'm going to present here is the mangrove monitoring in India project that was undertaken across India, right, as you see in the map below. And it basically shows areas that work, what we intend to in terms of scientific capacity, knowledge. Basically, when you do the mangrove monitoring, coastal vulnerability and resilience determination by developing vulnerability indices, very much important. Then you also do ecosystem carbon stock assessment by following scientific responding to sea level rise by doing the elevation measurements, and then also understand the local hydrodynamics changes in water salinity, the hydro period, how the tidal duration, inundation frequency change. So all of this was undertaken under part of this mangrove monitoring. Very first, very across the scale, across India, various sites, and try to develop mangroves in India. Coastal system is responding to these larger global changes. So as a robust scientific protocol, this allows for the systemic process to do the work, but also there is a continuity, there is a applicability, the process. Then under following this protocol, you do the assessment of total ecosystem carbon stock, soil acquisition, erosion, and greenhouse gas emissions. So taking a good picture of the ecosystem as a whole, not only from the context of carbon stocks, but also the context of vegetation, what is growing, what is surviving, what is taking maybe there's changes in species composition and trying to understand what is happening there. Also, what happens is, these are some of the pictures from the field conducting the work. Water depth and salinity data loggers that measure changes in salinity and hydrology at a very short time duration, so up to 15 minutes frequency. What they allow is once you deploy them in mangroves, what it tells you is how and the conditions saying across the day and night, across seasons over time. These are the photos of installation of these depth sensors. And this is one of the preliminary readout of those data. So what you see here is loggers, these data loggers, depth sensors were installed. What you see on the left is close to creeks. So what you see is very nice is in the black frequency across a duration of about 2 months. What you see on the right is deployment, which is further away from the creek. So you see the peaks are not as, that means which is very clear when you see the vegetation change. One is closer to where Abyssinia patch is there, and then DL1 is closer to Rhizophyra patch. So what we see is actually why these are the reinforcing functions, that the water, the hydrology, salinity is creating these conditions where one species survive predominantly and the other cannot survive. So basically trying to understand the underpinnings of the forcing functions due to environment. And sensitive instrument called rod surface elevation table, we call it RSET. We're trying to understand how elevation changes are happening. So in mangroves, what happens is over time in response to sea level rise, and if the sea level rise is small, then mangroves are able to keep up. But when in the increased sea level rise condition, mangroves may not be able to keep up. So how do we determine those millimeter level changes? So you do it by lead-210 radionuclide tracers and also RSET. So this is just RSET. It is not an easy thing. Basically, this is a process which takes place 2 to 2.5 an hour. This is compressed in 35 seconds. You drive down these steel rods on the mangrove sediment up to the bedrock, and then you basically sort of a semi-permanent structure which is not going to change form. As you can see in this video, there is a little notch there, which allows you to come at a later stage and measure how the sediment and how the surface has changed over time. So it is not an easy thing to do because you have to not only organize everything, but all these are set. And then you have to go there and do periodic measurement. So this is from Andamans. We have RSET installed throughout the north and south of Andaman. And then we have also data loggers installed to understand how mangroves are responding, whether there is a difference between north end to south end. And this is a map of sites that we have installed RSET differences across the creeks, across the area. This is from Sundarbans, where we have installed almost about 24 of these RSETs. This is very difficult area. This is a tiger reserve. Forest department doesn't allow people to go into this area, but we managed to, right? And as you can say, this has been distributed across the entire Sundarban mangrove forest area, not just one island, not just one area. The idea is to have the sufficient robustness in the data that you can derive conclusions. This is Bhitarkanika in Orissa, where we have installed about 13 or so of RSET. What you do is once the RSET the measurement, so basically you come back to the same site, you locate your site, then you bring what we call a measurement arm, which has a horizontal arm to it, and it has notches, which you can use to suspend these white PVC pins. So what you do is you are measuring the depth of these pins. So over time, if the length of these pins suspended, that means there is a change in your surface elevation. So you do this measurement 3 or 4 times a year. And if you see that the depth of these pins is decreasing over time, that means there has been accretion. There is sediment which is coming up. If the depth of these pins is increasing over time, that means erosion is taking place. And these are very sensible. But that gives you in situ real time sort of data how these mangrove ecosystems are responding. You can't just ballpark it. You can't just see from your eyes. So the RSET, that is why it is important. This kind of data, unfortunately, doesn't exist from any of the mangrove sites of country. And we are also combining this with lead-210 measurements. And then when we do and conduct these exercises, we also take the total carbon stock estimates to understand how much carbon is stored in mangroves and soil. These are all aspects that is very, very important and can provide all the mangroves are responding, how our ecosystem sustainability can be underpinned with this data. So what I've tried to paint a picture right here is how this exercise is done. It is difficult, but with following a protocol, with following a methodology, it's the sort of a foundation for any kind of informed policy. But while we do that, in the sidelines, what also happens is training and capacity building. When you go out and conduct these exercises, you inadvertently involve a lot of people, a lot of members of the staff who get to know about the importance, who help you out in the field and learn, and it automatic understanding develops about the importance of these ecosystems. You follow it up with communication and outreach. So you not only have to have your info briefs and flyers and informing common public, but also scientific output in terms of research. One of my advisors earlier told me that if you don't publish, it becomes research is more like tourism. So following that, it is very important that you publish or where it can be used for understanding for peer knowledge. You also provide the data sets and data face for larger use. As mentioned before, we have a term, the data is in public domain and where it can be used. And then what also try to simultaneously to generate awareness and engagement. So awareness through webinars, seminars, talks, conferences, but also engagement through either social media or organizing events such as India Mangrove Conclave, which we conducted in December 2024. I'll encourage people to go and have a look because it was very seminal gathering of mangrove researchers. In 300 registrations happened, and more than 100 institutes were represented. And it was divided into two themes of mangrove ecosystem scientific research and best practices, and mangroves for adaptation, biodiversity, and human well-being. So what it did is to bring together mangrove researchers of the collaboration, the support that is needed to work in a difficult ecosystem, in a difficult circumstances, and in a country as vast as India. So having provided this snapshot of what we've been doing in terms of forging partnerships, how does it fit into big picture? Because we all are very good in our own little cubicle or our desk when we do, but it does have to fit into big picture because the challenge is large, because climate change is a global challenge, because it doesn't just impact one small area, but it impacts large number of people, communities across the world. So when we think about mangroves or coastal sound science, how does it relate to the larger goals or targets that we have set? So when we look in the context of India, India has committed for emission reduction targets under its NDCs with a net zero target that our Prime Minister has announced in the last COP. Can allow us to reach that goal because these areas or these ecosystems can harbor a lot of carbon. In terms of biodiversity targets, such as National Biodiversity Strategy Action Plans, are rich hotspots of biodiversity and can provide a lot of area to meet those targets. I have already indicated sustainable development goals, how they are important. And then when we think about Bond Challenge restoration, and then this is the year of UN Decade for Ecosystem Restoration. So that's where brings us to restoration, even MS example, where they have done successful restoration across many years in various states. So whether to plant or not, when do you do interventions, understanding interrelationships in coastal setting where we involve local communities, all of these are very important. But this can be rooted in some kind of inquiry, a scientific inquiry taking into consideration. So that allows us to see the problem holistically. And if I can bring your attention to this book or report rather, which came out in 2002 by MSS RF, where they have celebrated 1990 to 2000, the decade of mangrove. So about 25 years ago, MSRF has done some really pioneering work under the guidance of MS Swaminathan sir, and then showed it's a very, very thorough report or book. I would encourage people who are interested in mangroves to take a look. So I leave you with some of my reflections in terms of mangroves, how they are the pillars of coastal sustainability, and why it is important to understand the complex coastal landscape. Collaboration and partnership for management is of very essential and paramount importance, particularly involving local communities. And then what we have to do collectively is to consistently following scientific methodology, have robustness and integrity in our efforts. Student and young researchers are very important because this is not an easy task, and we need all the effort, all the capacity, all the intelligence and smartness of a younger generation to be able to tackle it. And then when it comes to mangrove monitoring, scientific principles should embed the locally appropriate monitoring schemes or indicators that will allow for continued assessment, not one time, not two times, but long-term continuous monitoring is important. That can tell how mangrove health has been improving or degrading over time. It has to be inclusive. So with that, I thank you all. I'll be happy to take any questions. And I leave you with one last thought, which is to ask good questions. Which is the important thing is to ask why, and then maybe if you are bold enough to sometimes ask why not. So thank you so much.